In the previous video, we stopped before showing you some of the consequences of focusing on the Angular solution without taking into account the differences compared to the native application. Remember that we had defined a DSO tree to implement the style of the desktop screens of the Angular application. Where this was the root DSO, the DSO we indicated for the platform, both as default for all platforms, and as default for all Angular screens. That was going to be inherited for Web Desktop and Web Big Screen. For these others, we'd customize them with these other DSOs. All these DSOs were built on the base DSO, in which we define all the general tokens of the application, both the color tokens with their light and dark variations, such as those for fonts as well as those for font size, and we had also added there the fonts and typography classes that we had identified in the preparation stage. You may remember that then we'd already analyzed the variations that the font size tokens would undergo according to the screen size, and we had also identified some variations for the typography classes. And we had expressed all this in two parallel DSOs. Thus, for tablet, we had created this travel agency tablet DSO, where we had specialized those variations that we had identified. We should, in fact, call it similarly to its desktop parallel, travel agency base tablet. And it should import the travel agency base because it specializes it. By importing it, what it does is to change the values to the font sizes tokens. It also adds classes that were not needed for desktop, but are needed for this other screen size. Of course, we'll need to have the root DSO, travel agency tablet, which is the one we indicate here for web platform of that size. And if we want the same DSO to also work for the native application in this size, we can place it here as well. And the same will be true for phone size. Here I've already created the parallel structure. This was the DSO that we had created in the preparation stage. I renamed it, to which I had to modify some things that I need you to see to illustrate the point. Since it matters to the desktop analog, only the tokens that change should be here, and not the ones that keep the same values, such as the color tokens. Why then do all these color tokens appear instead of just the font size tokens? Don't mind this. I had to temporarily copy all the desktop tokens whose value used another token, because this indirection is not working for the native application. I had to assign their absolute values. This will be fixed, so don't worry. This whole section will be gone when this bug is fixed. What we do have to worry about is how we define the fonts. Before, all these classes are the ones we had identified in the preparation stage. The application and application bars classes will have special semantics for native applications, as we'll see later. I will not show them now. Now let's turn our attention to the fonts. We'd inserted as files in the KB the non-default fonts that we were going to use. For example, all the Hebo fonts of different weights, remember? But we'd integrated only those of WAF2 format, which, as we had said, were the best for Angular. However, as we also said at the time, they cannot be used in native environments. That's why I added the same fonts, but now in TTF format. If we had used for Angular the TTF ones instead of the WAF2 ones, we would not have this problem. Although the TTF fonts are not the best for Angular. What should we do then in this case where we have the two types of fonts? In the base DSO for desktop, we had the font face rules that declared the fonts. Clearly, we'll have to specialize them for our DSOs for native applications, so that now they take the TTF file and not the WAF2. That is, we would have to copy for both travel agency based phone and travel agency based tablet all of these font face rules and simply change the file to the TTF. But what if we want to use WAF2 for the Angular application in phone and TTF for the native one in phone? There we will have no choice but to specialize. That is to say, to have a DSO tree for the web phone platform and another for the native ones. Then we would specify here the default for phone that we'll want to apply only to the native ones, and here its exception, the one for the web, that will use the WAF2 format. But we have a bigger problem than that. Let's assume we use the TTF fonts for Angular as well. The problem is that we had built a solution in Angular taking advantage of the fact that we could specify properties that were valid as default for all classes by specifying them under the application class, remember? And that's how we decided to call all of them Hebo regardless of their weight, and then differentiate them by the font weight property. In this way, we were able to define a primary token for the Hebo family, and in the application class, indicate that this will be the default family. In this way, in the classes that use that family, we didn't have to indicate the family, but only its weight. Here there are two assumptions that don't work in the native world with Genexus, at least not for the moment. One, that the property specified in the application class will be valid by default for all classes. This is true for the Angular world because that class is applied to the body tag of all HTML pages. But in the native world, that class only controls some general behaviors of the application, like the colors of the application bar, actions, and so on. So if I place the font family property here, it will not be valid by default for all the controls of all the screens. And second, and even more important, in Angular, since the font family names are repeated, what identifies the font is the name and weight pair. This is not the case, at least for the moment, for native applications. What identifies the font is the family name. So we have to give different names to the Hebo fonts. And the same goes for the other families. But this means we have to redefine all the typography classes. For example, these ones. This secondary font is Rubik, so we have to make this change. And here's another one. But not only that, but also the classes that we didn't have to modify because they came from the travel agency-based DSO will also have to be modified. Here we see, and I take the opportunity to show you, how we have the class H1, to which we could also remove the font weight. And note two things. First, that if in this DSO that imports this other one, I want to change some properties and or add others to a class, I don't have to copy all those that don't change. Those will be valid. That's why I left all these commented, because they're the same. I don't have to indicate them again here, but I do have to indicate those that vary or are added. In this case, the line height changes between desktop size and phone size. But if it didn't change, the point I wanted to show you is that having ignored this difference between Angular and native applications regarding font definitions makes it necessary to specify all the typography classes in the child DSO, even if they don't change anything, just to be able to indicate the font family correctly. And this is expensive. If we had known beforehand, we wouldn't have chosen the solution that we implemented in Angular. If we don't want to touch the DSO for desktop Angular, we'll have to select all these classes, at least to change their font family indication. This is how the changes would look like. We have to declare the font face rules to identify the font family uniquely by name. And then we have to add all the typography classes, even if only to indicate the font family by name. I changed something else in these ones. And I didn't analyze these others to see if I should change anything else. I only changed the font family. But note that I had to do it one by one with all of them. This was probably troublesome for you. It was just one example of the obstacles that can emerge when implementing multi-experience, and that can be reduced to a minimum if you know the differences from the beginning of the development. The reason is that native applications haven't been built on the CSS paradigm, and this will have an impact. Although the aim is to bring the two worlds as close as possible in Genexus. To inspire you, I advanced quickly in my KB so that you can see in this emulator how the screens of the Android application for phone look like. For example, we see the hamburger menu on the left, as is the standard in their operating system, and not on the right, as proposed by Chechu's design. We see as title in the application bar the name of the object being loaded. And not this icon and text that I'll show you later how to change in the simplest way. Note that in the Attractions panel, I removed the header as indicated in the design, and that for now, I implemented the carousel as a horizontal grid to make it quick and easy. And that if I tap on an attraction, it takes us to the attraction panel. And automatically, and also according to the operating system's own mechanisms and Android's design guides, the back button appears to return to the object that called it. Okay, I'll stop here so that it doesn't become boring, and we'll continue in the next video.